All right, welcome everybody to this happy Friday. I hope that you all had a wonderful spring break. I know that I did. We are going to be covering the end of Unit 3 today. So we're going to work on 3.11 and 3.12, which is ratios of areas and volumes. And then at the end we'll do a quick Unit 3 review also, because next week you guys have your test. So you'll have your test, I think, on Wednesday. And then our Friday session is going to cover Unit 4 stuff. So this is our last time together covering Unit 3, so make sure you take really good notes. And if you have any questions, if you're at home, you can always email me, call me, text me, and we can work them out. Or come see me in person. I love the students who come in person. So here we go. Today's agenda again is to do 3.11 and 3.12 in detail. Then we're going to review Unit 3 with a couple test questions. Yay, we love practice test questions where I just change the numbers, but it's the same kind of question. Your essential question for today, I'm going to pause for a minute while you copy this down. It's using what you know about the ratios of areas of similar figures. Please provide an example of a similarity ratio, then give the area ratio for your example. So we're making our own examples today. You're going to give me a similarity ratio, then you'll give me the area ratio for your example. If you're taking good notes, this is going to be a very easy question to answer by the end. So I'll pause for a second while you copy that down. If you're watching from home, please give me a green check mark when you are ready. Okay, again, if you're at home, please give me a green check mark when you're ready. I see that 5 of us are ready to move forward. Mr. Hayden's ready to move forward. So if you're not quite done copying that down, it will be up again at the end of today's session. So here we go. On your slides, hopefully you have them printed out. I give you 99% of the notes that you need. You just have to add in your work, things like that. So hopefully you printed that from the K-mail that I sent you this morning. And if you're in person, I provide you a copy. So what we're going to do today is we're learning about how can we use ratios to solve for area. You guys see my shape down below? What is it, a hexagon? Yeah, it has 8 sides. Before, when we used to have to calculate area, we used to have to figure out what's the area of one triangle, and then we'd multiply times 2, 3, 4, 5, 6, 7, 8. We'd have to multiply by 8. And that was a lot of work, finding the area of one triangle and multiplying times 8. It was a lot of work. So today we're going to use a shortcut. We all love shortcuts. How to do it the long way first. Now we get to do it the shortcut way. So the scale factor is going to be represented. Can you guys circle this or point at it on your notes? The scale factor is represented by A to B. There's another way we can write this, and I want you to add this onto your notes. The other way that we can write a ratio is as a fraction. That's usually how we see ratios, so please add that to your notes. Instead of A colon B, we can say A over B. It means the same thing. And then today for area, look how we can represent area. Area is going to be A squared over B squared. So whenever you see the colon, what does the colon mean? It means it's a ratio. How else can we write ratios? As a fraction. So let's try a few. Let's see how easy these are to use. Because this old way of finding ratios and finding area was tough. It took us a long time. Now we have an easier method. So there's several ways that we can use the ratio. And here we go. So we're going to try this one. The scale factor of 2 similar triangles is 3 to 4. Did you guys notice that I read the colon as the word 2? So that really says 3 to 4. So we're going to write it as a fraction. And I put an S under it because that's their similarity ratio. How do I find, it says what's the ratio of their areas? How am I going to find the area ratio? So I'm always going to have an S first, then I'm going to have my A column. If you've already tried your homework, then you've noticed or asked me questions about it. I kind of prepped you that this is where we're going. So to find the area, we just square both of them. So what would the area ratio be? 9 to 16. That's it. You may be thinking, where's the trick? There's no trick. That's all there is to it. Let me grab my pointer finger. Here we go. So if your similarity ratio is 3 to 4, how do you find the area ratio? You square both numbers. That's it. That was easy. Let's try this one. The scale factor of two similar triangles is 15 to 25. What's the ratio of their areas? So we're going to write my S with 15 to 25. Now, before you go any further, before we go to my A, I have to ask you a question. What do we notice about our starting fraction? Do we see anything? I can simplify it. So 15 over 25 can be simplified. Anytime we're talking about these types of problems, before we square it, before we jump to the A column, I have to simplify it. So what can 15 and 25 both divide by? 5. So 15 divided by 5 would be 3. 25 divided by 5 would be 5. So my S is really 3 over 5. Everybody okay? Just reducing a fraction? So now if I want my area ratio, I take my simplified version and I square it. So my area ratio would be 9 over 25. And you're going to see, if you already tried the homework, that the answer that's in the back of the book is always simplified first, then they square it. That's what we have to do. Those are our steps. Let me pause real fast. Are there any questions about anything we have done so far? Right. Good question, Austin. He asked, should we put this in decimal form? No. I'm going to show you why when we get to shapes in a minute, because each part of the fraction is going to refer to a different shape. So the 3 is going to be on one shape, the 4 is going to be on the other shape. The 9 is going to be on one shape, the 16 is going to be on a different shape. So we need these two numbers to stay separate so that I know, hey, this belongs with the little figure, this belongs with the big figure. And it will make more sense when I show you a drawing in just a moment. So you're always going to leave them as fractions. Good question. So let's see how we're going to use it. Yay, I no longer have to calculate area the old way. I get to now use what we just learned to solve for the area. It says if two similar octagons have a scale factor of 2 to 7, and the smaller octagon has an area of 12, what is the area of the larger octagon? So we're going to start just like we did the last problem. Let's do my S column. Let's do my A column. So S, what's my similarity ratio? 2 to 7. Everybody okay so far? Can that be reduced at all? Can 2 7s be reduced? No. So go ahead and write your area ratio now. You try it. What would be your area ratio? How do you go from similarity ratio to area ratio? You have to do what to them? Square them. Oops. Squared. So I'd really get 4 over 49. Okay, I'm pausing right there. Does anybody have a question how I did that? So each time I'm going to write my similarity ratio, you're going to write your area ratio. Now I'm going to look at the rest of my problem because this gave me one more piece of the puzzle. Can you underline this with me in your notes? The smaller octagon has an area of 12. What we're going to do now is we're setting up proportions. I'm using my area ratio, 4 over 49 equals, and I need to plug in the rest of my proportion. 4 is going to belong with the smaller octagon. 49 belongs with the larger octagon. How do I know? Because it's the smaller number, it's the bigger number. Like there's no other reasoning behind it. So 4 would go with my smaller, 49 goes with my larger. So think about it. Where's the 12 going to go? If the 12 is smaller, it's telling me smaller octagon has an area of 12. Would 12 go on the top or the bottom? The top. Good job. Let's put in a 12. It's saying what's the area of the larger. That means I don't know the larger. So that one's going to be an X. When I have two proportions, how do I solve, you guys? I have to cross multiply. So let's do that really fast. 4x equals 49 times 12. which means 4x equals, and it's absolutely acceptable to use a calculator, 588. I'm doing it for you. Last step, how do I get the x by itself? Divide by 4. Good job. So by the time I'm done, I get x is 147. So the area of my small octagon is 12. The area of my large octagon is 147. So let's talk through the steps one more time before we try another example. Step 1, write your similarity ratio. Easy, they gave it to us. Step 2, write your area ratio, which means you square both of them. From there, I set up a proportion. 4/49 equals my small over my large, and we solved just like we solved last week. So it's just one new piece of the puzzle, which is how to find your area ratio. So we're going to try this again, because practice makes perfect. So let's try example 4. Example 4 says, if the ratio of areas of two similar rectangles is 9:49, find the scale factor. So let's write my S. Let's write my A. Which one did they give me this time? Can you read through the problem again? Did they give me S or did they give me A? What did they give me? They gave me A. It says the ratio of areas is 9:49. So where does 9:49 go? Above the A. Good job. This time they're asking me to find the scale factor. So this time they want the S. So can you guys think for a minute? To go from S to A, we square them. How are we going to go from A back to S? Square root them. Good job. So we can think in our head, what number squared is 9? What number belongs here? 3. Great job. What number squared is 49? 7. Great job. You guys found the similarity ratio. See how it goes back and forth? So if I am going from similarity ratio to area, I'm squaring the number. If I'm going from area back to similarity ratio, you're square rooting it. So they're opposites of each other. If you can go one way, you can go the other way. So we're going to try another one. Number 5 says, if the ratio of areas of two similar trapezoids is 1:100. We're going to stop right there. Let's fill in what we know. Here's my S. Here's my A. So my same question to you is, which one did they give us? Did they give us S or did they give us A? Read through my question. They gave us A. Great job. They gave us the ratio areas. So my area is going to be 100 to 1. Everybody still with me? When you know one, you do know the other one. So let's try and do S. Think about it. Try and write it on your paper before I ask you out loud. Fill in S on your paper. If you're at home, I'd like you to type in your answer. So if you're in the room, what number squared is 100? Number 1. 10. Yep, we're going to take them one at a time. 10. What number squared gives you 1? What times itself as 1? 1. So let me pause for a second. Are there any questions about how we did that? Going to area, it's squared. Going back to the similarity ratio, it's just the square root. Now let's read the rest of my question. Find the length of the leg of the smaller trapezoid if the leg of the larger is 14. Can we underline that last part? Leg of the larger is 14. Leg of the larger is 14. So here they're saying this one's 14. What is the little one? So here's my question to you guys. I know I'm going to have to set up a proportion, right? I'm going to have to say something over something equals something over something. Which, don't answer yet, which ratio do I have to use for one of them? They're asking me to find a leg. Is a leg considered an area ratio, or is a leg considered just a similarity ratio? Which one would a leg be considered? What do you guys think? A similarity ratio. Good job. So this time they're not saying compare the area and compare the area. They're saying compare a leg, compare a leg. Which one's the leg? The similarity ratio. So this time I have to use what's under my S. So I'm going to say 10 to 1 equals, let's read my question again. Find the length of the leg of the smaller trapezoid if the leg of the larger is 14. So think about, where's the 14 going to go? 14 is the larger. Okay, so we had a little bit of both, which is fine. So 14 actually belongs with the larger number, right? It says 14 is larger. So let's look at my two numbers. I have 10 and I have a 1. It's going to go with the larger number. So the larger number is 10, so it's going to go on top, 14. Smaller, I don't know. It's going to be the x. We're going to cross multiply and solve. So I will get 10x equals 14. Divide by 10, and I'm going to get the x is 1.4. So when we're setting up this proportion, number one, you always need to find S, you always need to find A, now that we know how. And then we have to decide which proportion am I really using. What are they asking me in the question? If they're asking me about area, I'm going to use area. If they're asking me about a side length, I'm going to use my S. Good job. You guys are doing great. So now I have one last thing to teach you, and I know you're thinking, yeah, my brain's sort of swimming already, but it's building on what we know. So check this out. Your scale factor is A to B. Area is A squared to B squared. Look at volume. What's the only difference about volume? It is cubed. Doesn't that kind of make sense when we're talking about units anyway? When we're talking area, don't we always say that it is like centimeters squared? What's volume? Centimeters cubed? Oh, they kind of relate, right? It's in the same realm. So let's talk about how we're going to use these now. We're going to practice. Number one, if two similar pyramids have a scale factor of 5 to 8, what's the ratio of their areas? What's the ratio of their volumes? So this time I'm going to have an S column, an A column. Guess what my last column is going to be? A V. Add this to your notes. So above my S is going to go 5 to 8. What's going to go above my A? 5 squared over 8 squared. Good job. Which is really 25 over 64. What do I do for B? Or for V, sorry. 5 to the third over 8 to the third. Good job. So 5 to the third is 125, and 8 to the third is 512. So let me pause for a second. Does anyone have a question about how we went from S to A to V? So the original, squaring it, cubing it. How did we do? We just added that last column, right? That's all. Let's try a problem. Hint, hint, this is like your quiz questions. It says if two similar cones have a scale factor of 2 to 3. So let's stop right there. Which one did they give us just now? Did they give me S, A, or V? Which one did they give me? Scale factor. S, right? Scale factor or similarity ratio is always S. See how they start with an S? Scale factor, similarity ratio is always the S. So above the S, I'm going to do 2 to 3. And the smaller cone has a volume of 64. So I'm just going to underline that a little bit. Smaller cone has a volume of 64. Find the volume of the large cone. Well, I can't do that until I fill in my A and my V. Now, technically, in this example, nowhere are they talking about area, but just for good form, I always do S-A-V every time, because that way I know that I haven't made a mistake. I'm always going to do my S, then my A, then my V. So A, just for good practice, 2 squared over 3 squared, which is 4 over 9. And then my V column would be 2 cubed over 3 cubed, or 8 over, anybody know 3 cubed? 3 times 3 times 3? 27. Good job. So let me pause for a second. Are there any questions about how I found my S, my A, or my V ratio? So you like it when the end of the unit's not that bad? Shocking, right? Usually the end of the unit's kind of crazy scary. So now is when I'm going to set up a proportion, because it's asking me to solve something. It's saying the smaller cone has a volume of 64. Find the volume of the larger cone. So I'm going to change colors here. So Austin's asking if either the A or V can be simplified, do you simplify it? And the answer is yes. So 4/9 can that be simplified? No, so we're going to leave it. 8 over 27, can that be simplified? No, so we're going to leave it. But that's a great question. So if they could be reduced, yes, we would reduce them. So let's come back to our question. I know I'm going to set up 2 proportions here. First, I have to decide which formula am I going to use. Am I using 2/3, 4/9, or 8/27? Look what the question's asking. Smaller cone has a volume of 64. So am I talking scale factor, area, or volume? What do you guys say? Volume. It says the word volume. So which proportion am I using? The volume proportion. So I'm even going to circle it. So I'm going to say 8 over 27 equals, now before I put my numbers in here, 8 is the smaller number, 27 is the larger number. Everybody okay with that idea? 8 smaller, 27 is larger. So up here it's saying the smaller cone has a volume of 64. Would 64 belong on top or bottom? 64 is smaller. Which one of these 2 is smaller? The top, so it belongs on the top. When we set up proportions, it's easy when we have a picture, right? We go small is to big as small is to big. Without a picture, we still just have to keep the same consistency going. If small's on top, small's going to be on top on the other side. So we're going to cross multiply and solve. So I would get 8x equals 27 times 64, which is a really big number, 1728. And when we divide that, which you are allowed to use a calculator, we would get 216 for the volume. So what we're keeping in mind as we're working through 311 and 312 is how do I find S? Usually they give you S. How do you find A? Square it. How do you find V? Cube it. If it's a problem that's asking you to solve something in addition, we have to decide which of the 3 formulas am I using, and then match up the information on the other side. So here's one more. One more of this kind, and then we'll do our Unit 3 review really fast. Says if 2 similar cylinders have a ratio of volumes of 64 to 125, find the ratio of their areas. Whenever we're given these problems, what letters are we going to write? S, A, V. Which one did they give us this time? They gave us the volume. So where's that fraction going to go? Above the V. So let me pause. Any questions about how I did that? Whenever you have problems like this, you're going to put an S, an A, and a V. You have to fill in what they gave you. This time they want to know the ratio of areas. They want to know this one. Boy, how do I go from volume back to area? Let me tell you, the easiest way to go is you have to go back to S first, then we'll go to our A. So, volume's cubed, right? Volume's cubed, A cubed over B cubed. How am I going to go back to A over B? You're thinking cubed root, exactly. Or you can think to yourself, what number to the third power is 64? Meaning what times what is 64? Can anybody think of what number that would be? Okay, a couple people in the room have it. Anybody at home have it? What number to the third power is 64? What times what times what? And if you don't know, you could try it. 2 times 2 times 2, that's 8. 3 times 3 times 3, 27. So it's actually 4. And then on the bottom, there's a 125. So, it ends in a 5. That should be a clue about what kind of number it could be. What times what would be 125? 5. Good job. If you don't know these off the top of your head, how can I do these in a calculator? Somebody in the room said it. You can do the cubed root. And a calculator would do that for you as well. So if this is a cube, how do you go back to the original? You take the cubed root. So once I have S, can you guys go ahead and fill in A for me, please? That should be easy. Go from S to A. Remember, A is just the top squared over the bottom squared. So we would get 4 squared over 5 squared, which would be 16 over 25. So that's what they were asking you for in this problem. Questions, comments, concerns? We okay? S to A to Z. Original, squared, cubed. So that's all there is for 311 and 312. We're going to spend probably the last 10 minutes or so just doing a quick review of Unit 3 so that you are ready for your test. So the next couple slides are all review slides. What we learned this unit is about dilation. So dilation, and I know there's like a lot of jargon going on here, so kind of let me break it down for you. And probably if you don't have a color printer, these are not in color. So what I would probably do is something like this. See how the pre-image is in green? I'm just sort of going to make it a squiggly line, and I'm going to point to the green one on the inside because I know that your notes are not color-coded like this is. So can you do like a squiggly line under pre-image and point to the green triangle on my screen? So that's like the little one inside. So watch what it's saying. When you go from this green one to the purple one, what happened to the triangle? It got bigger. Bigger means greater than 1, which makes sense, right? If something's enlarging, what kind of numbers are greater than 1? Timesing by 2, timesing by 3, it's getting bigger. So it kind of makes more sense when you think of it that way. On my right-hand side, if your pre-image is bigger, and then it turns into the purple one, what happened to your shape? It's getting smaller. What kind of numbers are smaller? We talked a little bit last week. They're fractions, right? They're your numbers in between 0 and 1. So can you just add that to your notes real fast? So it's going to get smaller. I'm going to add those words in. Smaller when you have a fraction. And it's going to get bigger when you have numbers that are bigger than 1. Which makes sense. Because if you're timesing by 2, it's getting bigger. If you're timesing by 1/2, what's half of something? Smaller, right? If you eat half of a pie, did you eat the whole pie? No, you ate a smaller portion of the pie. So it's getting smaller. That is all that jargon says on this page. Then we talked about similar triangles this unit, and you need to know these 3 for the test. Can you put a big star by these 3 in your notes? How can you prove that something is similar? Angle, angle, side, angle, side, or side, side, side. Those 3 you can use to prove that they are similar. We talked a lot about the difference between congruent and similar. It was even one of your essential questions one week. Congruent is when they have the same angles, the same sides, everything's exactly the same, right? It's the same shape. Similar, they had to have the same angle, but the sides could be smaller. They just had to be proportional. So highlight those three in the corner. You need to know that those three prove similarity. They're linked. So those three prove that they're similar. Do we remember the symbol for similar? The one squiggly line? Okay, so one squiggly line means similar. Then last week we got into, this is called the side splitting theorem. This is what we ended last week with, and it's what you started this week with on Monday. Basically we just set up proportions. So what we learned is there's a couple ways to set it up that would be correct. I could say 8 is to 10, top is to bottom, as, how would I set up the other side? If I did the 8 first, the 6 would have to be on top, good. As 6 is to x. Then you would solve it by doing what? Cross multiplying, right? Can you guys set up the proportion for the bottom for me? Let's write our numbers in. So it says S to U is 3, add it to your picture. S to W is 12. T to X is 16. And I want you to find T to V, so I'm going to put an X there. So let me give you a moment. Can you please set up your proportion? Okay, is anybody brave? Want to give me their proportion in person? Tyler, you want to?
No.
Okay, something else? Yeah.
3 over x equals x over, 3 over 12 equals x over 16.
Okay, so she did 3 over 12 equals x over 16. Look what she did. So small, you guys looking on the picture? Small is to the whole side, as small is to the whole side. That's acceptable. There's more than one way to do it. Anybody do it a different way? What if I did 3 is to x? See how I did small is to small, as big is to big. That would be acceptable also. Okay, so there's lots of ways to do it. This is like key right here. So consistency is key. So if you do small is the whole side, small is the whole side. See how you just have to stay consistent with how you're setting up each side of the problem. You'd cross multiply and solve. The top answer, in case you want to go back and try it later, is 7.5. The bottom answer is 4. That way you have them and you can check them out later. Next on the test, you just need to know some vocabulary. So I'm going to point to some pictures for you. Again, these are on your notes, so just draw little arrows in. An altitude is like this first picture. An altitude is where it makes that 90 degree with the bottom. That's an altitude. Just draw a little arrow with me. A median is when it cuts it in half, like here. See how it's cutting that bottom in half? That's what those tick marks mean, that the two sides are equal. That would be a median. Angle bisector is when it cuts the angle in half. So that's this top part of the picture up here. And lastly, parallel segments would be this middle one, and they really should give you some kind of an arrow to show you that they are parallel, or it would say it in the direction. Just make sure you're comfortable with that vocabulary and you'll be just fine. And then the last kind of problem that you guys are going to see on the test is what we call indirect measurement. And these are taken exactly from the test. I just changed the questions, the numbers. Hint, hint. It's like when we're using proportions to find the heights of trees, of buildings, you know, of all those things. Because skyscrapers, you think they take a ruler to a skyscraper to see how tall it is? No, they use proportions, like what we're going to do for geometry. So we're going to try one. Let's try this top one together. I'll call it number 1. says find the height of the cell tower. There's really two triangles going on here, which is why I can use proportions. Let me draw in my triangles here. So I have my little triangle in blue. My little triangle's in blue. And let's put my big triangle. I'll highlight my big triangle. I'm a visual learner. I like to highlight things, color things. So anytime you have colors at home, that would be great. Is everybody okay seeing the two triangles that I see? Your little blue triangle, your big yellow triangle. So when I'm setting up for proportion, I need to do little triangle is to the big triangle when I need to stay consistent. Okay, so let's try. I'm going to do my little triangle on this side, my big triangle on this side, but again, there's more than one way to do it. So I'm going to say 3 is to 4. So look at how I set mine up so far. I did the height is to the bottom. Is everybody okay with where I put things? The height is to the bottom. So on the other side, guess which one I have to do first? Height is to the bottom. So what's my height? I don't know. I'm going to put an X. Here's the tricky part. What's the bottom? Is it? That's the question. So I see some people are typing 36, some people are typing 40. So again, this is why I color-coded them. We're talking blue triangle is to my highlighted triangle. 3 is to 4 as X is to, I have to do my whole side of my triangle, because isn't my whole triangle in yellow? Yes. So what's the whole bottom of my yellow triangle? 40. See how it's the 36 plus 4? It makes more sense when it's color-coded, because then you can see it. What's my blue triangle? A 3 and a 4. What's my yellow triangle? I don't know, and the whole bottom of my yellow triangle is a 36 plus the 4.
So you got to look for the lines that divide it.
You do. You have to look for the lines that divide the triangles. Exactly. So what I really have here is 3 over 4 equals X over 40. So when I cross multiply, I'm going to get 120 equals 4X. So my X is going to be 30. Because here's the deal, you guys. If you use 36, that's not part of your triangle. That doesn't make a triangle. Look what it really makes. If I only went to here, that's this weird triangle. That's not similar to my blue one. That's a whole entirely different shape, different everything. So I cannot stop at the 36 because that's not part of my big triangle. Did you guys see the difference? Little triangle is to the big triangle. So it's not this green one. The green one's the wrong one. Let's try that idea again down here at the bottom. So let's try number 2. And I bet you're going to set it up correctly the first time this time. So I have my big triangle I'm going to do in yellow again. And my little triangle I'm going to do, let's say red. Except I can't draw a triangle to save my life. Sorry. Let me give you a moment. See if you can set up your two proportions. We're trying to find the height of the flagpole. That's right there. There's more than one way to do it, but I'm going to do little triangle first. So I'm going to say X is to 9. Look how I set mine up so far. Height is to the bottom, which is just what I did before. Height is to the bottom, as height, so the 76, is to the bottom. But the question becomes again, what's the bottom? I'm talking my yellow. It's the 48 plus the 9. 48 plus the 9. So that would be 57. Cross multiply. 9 times 76 is 84 divided by the 57. So my x would be 12. So really the key with these problems that I'm trying to get you guys to point out to you is that you have two triangles going on here. You cannot chunk up your triangle and stop at the 48 because that doesn't make a triangle. The whole thing makes your big, huge triangle. Everybody okay with that idea? These are coming on the test. Same problem, different numbers. You can do it. Now you have really great examples for yourself. So let's again remind ourselves of our week 12 essential question, which is you are going to come up with your own example of a similarity ratio, and then you're going to tell me your area ratio. So what am I really asking you for? I'm asking you to give me an S that you're making up, give me a top and a bottom, then give me an A, give me the top and bottom. If you practice what we practiced today, it's really easy to make up an S and tell me what the A is. You would know how to go from one to the other. So if you're at home, please put that in the drop box. Label your first one with an S, label your second one with an A. So I hope that you guys have an awesome weekend, and I will see you next week.